Good morning, everyone. Our group will talk about some properties on steel, on steel, and followed by the ultrasound non-destructive testing and radar and EM wave non-destructive testing on steel structure, and a description on steel formwork. Let me first introduce the properties of steel. Steel is an alloy of carbon and iron, and the properties include high strength to weight ratio, which means that with only little weight it can acquire a very high strength, and it is very favorable for construction design. And other properties include ductile, hard, and steel is also an electrical conductor. Also, it has good fire resistance, which makes him very favorable in construction structural design. In construction industry, there are mainly three kinds of steel, including carbon steel, alloy steel, and stainless steel. Stainless steel, we have added the chromium and nickel to make him resistant on corrosion. And carbon steel means that the steel only composed of iron and carbon with no other substance. Ultrasonic non-destructive.
I'm going to talk about the ultrasonic testing. First, about the theory and principle, the ultrasonic testing is widely used in finding cracks and defects. Also, it's used to calculate the thickness of steel paint and casting. To achieve the above goal, the ultrasonic test make use of principle of sending the sound wave through the steel and analyzes the received wave to locate the cracks and measure thickness. For wave propagation, there are four types of wave: longitudinal wave, shear wave, surface wave, and plane wave. Longitudinal wave is also called the compression wave. It is widely used in ultrasonic testing. Longitudinal waves exist in solid, liquid, and gas. Compression wave transfer from the source by shooting action of a particle to the next, and then this particle is still vibrate at a frequency of ultrasound. It will oscillate back and forth by a distance that it is the amplitude of ultrasound. And we can see from the picture the longitudinal wave propagate in a longitudinal direction. For shear wave, from the picture we can see that the propagation is defined as a wave in which the particle oscillates at a right angle to the direction of propagation. Shear wave can only exist in solid material to form an effective propagation, but not in liquid and gases. Shear wave is relatively weaker than the longitudinal wave because of slower velocity and shorter wavelength in same frequency. For surface wave, which is a wave that the particle motion is elliptical and the ellipse major axis is perpendicular to the direction of propagation and the propagate parallel to the surface. For the plane wave, it is also called lump wave. Plane waves are similar to surface wave, which have a particle motion that is elliptical and the direction of wave propagation is parallel to the surface. Let me talk about the property of sound wave. There are two types of sound wave, that is reflection and refraction. Reflection, you can see from the picture, this one, the wave transfers in reflection case. A compression wave strike in the steel to air interface at the angle of incidence to the normal line, and the wave reflected and form compression wave, which is reflected angle equal to the angle of incidence. Moreover, there are also a wave converter, which is shear wave at angle S, that can deliver from shear load. If the steel plate is discontinuous, the wave will first reflect the continuous echo back to the transducer and further travels into the steel and reach the back surface and reflect. Therefore, we can find out all the discontinuity in steel by using ultrasonic test. For reflection, in the right hand side, the steel and air have different index of refraction. Therefore, when ultrasonic pass through an interface between steel and air in an oblique angle, both reflect and refracted wave is produced. Let me introduce the procedure of setting up the ultrasonic system. First, the pulse emit a short high voltage pulse to the transducer after receiving signal from the clock. At the same time, the pulse will also supply a voltage to the time-based ligand module. The time-based ligand module starts the spot in the CTL zone in the screen, and the voltage pulse will travel to the conductor and is converted to the magnetical vibration. Then it enters the steel pieces. The vibration will travel along the sound path in steel pieces. Spot is moving horizontally across the CRT at this process. The energy in steel pieces reflects from the back interface to the transducer, and then the transducer will convert the energy back to voltage, which this converted voltage is portion of its original value. The receiver or amplifier receives the reconverted voltage and amplified it. The amplified voltage is sent to the vertical plane in CRT. And there is another returning energy reflected off of the steel pieces top interface and make the second shift down through the test pieces. The above step repeat again and again until all the energy is used, and multiple repeat signals will show in the displays. And then there are different equipment in the ultrasonic system. First, let me talk about the transducer. The stick beam transducer is usually used for checking internal defect in pinball. The transducer emits the sound wave perpendicularly to the surface of part that is being examined. For the angle beam, it is usually used to introduce reflected shear wave into steel, and the angle sound path allows the steel beam being reflected off the back wall interface. For displays, there are three types of display presentation. For A-scan display, which is showing with a conventional ultrasound flow equipment, and the display presents the data ultrasonic in a horizontal baseline and vertical deflection based to the amplitude. For B-scan, it shows a cross-sectional view of steel, and C-scan is like an X-ray picture. It shows the plan view of steel pieces, but no the depth is obtained. After, my roommate will talk more about the testing.
Now let me talk about the technique and the application of ultrasonic test. There are two methods of ultrasonic test. One is pulse echo method and another is transmission. Pulse echo ultrasonic measurement can determine the location of a discontinuity in a part of structure by accurately measuring the time required for a short ultrasonic pulse generated by a transducer to travel through a thickness of material and reflect from the back of the surface of a discontinuity and be returned to the transducer. In most applications, this time interval is a few microseconds or even less. The two-way transit time measured is divided by 2 to account for the down and back travel path and multiplied by the velocity of sound in the test material. And another method is the through transmission method. It will include transmission and reflection and conduction in this method. Angle beam transducer and wedges are typically used to introduce a refracted shear wave into the test material, like in this picture. An angled sound path allows the sound beam to come in from the side, thereby improving the detectability of flaws and around weld areas. In most applications, this transducer over the surface of stainless steel block and can see return echoes as they appear on the oscilloscope. The geometry of the sample is in this graph. The sound path will refract and to detect the defects. It can use to measure the thickness in plates or casting, and it can also detect any defect in welding or fatigue cracking. For some large area, it can also make corrosion mapping. Let's see 2 examples of the applications of ultrasonic tests. One is the rail inspection. Rail can be inspected by ultrasonic method. Both normal and angled beam techniques are used, and both pulse echo and pitch catch techniques are used. The different transducer arrangement offer different inspection capabilities. Manual contact testing is done to evaluate small sections of rail, but the ultrasonic inspection has been automated to allow inspection of large amounts of rail. Fluid-filled wheels or cells are often used to couple the transducer to the rail. BRE Rail Surface, which is one of the companies that perform rail inspection, use roller search units comprising a combination of different transducer angles to achieve the best inspection possible. This is showing how the RSU is used, and you can see that there are few ultrasonic wave produced in different angles, which can test different defects. For example, it can test the thickness of the material and also bolt hole cracks. Also, it can also detect some defect on the head cracks. And another application would be testing on the weldments. The most commonly occurring defects in weld joints are porosity, slag inclusions, lack of sidewall fusion, lack of inter-run fusion, lack of root penetration, undercutting, or longitudinal or transverse cracks, with the exception of single gas pores. All the defects listed are usually well detected by ultrasonic tests. Weld in aluminum can also be tested. Ultrasonic flaw detection has long been the preferred method for non-destructive testing in welding applications. Ultrasonic weld inspections are typically performed using a straight beam transducer in conjunction with an angle beam transducer and wedge. A straight beam transducer producing a longitudinal wave at normal incidence into the test piece is first used to locate any laminations in or near the heat-affected zone. This is important because an angle beam transducer may not be able to provide a return signal from a laminar flow. The second step in the inspection involves using an angle beam transducer to inspect the actual weld. Angle beam transducer use the principles of refraction and mode conversion to produce refracted shear or longitudinal wave in the test material. This inspection may include the roots, sidewall, crown, and heat-affected zones of a weld. This process involves scanning the surface of the material around the weldment with the transducer. This reflected sound wave will bounce off discontinuity plates at the path of the sound beam, and it can determine the location and type of discontinuity. Now, another groupmates will talk about the part of radar non-destructive testing.
I will first talk about the radar penetrating, ground penetrating radar with using the radar wave. The method of using ground penetrating radar is a non-destructive testing. The principle of the ground penetrating radar is based on the applying of electromagnetic wave radiation. The application of using the ground penetrating radar is widely used nowadays, including in the aspects of geotechnology, detecting the cracks, the location of material, measuring the diameter of material. Usually, microwave or radio wave is used for the ground penetrating radar testing. Thus, the wave is relatively high frequency in the EM spectrum. A testing method requires a transmitter like a GPR antenna. A testing method requires a transmitter like a GPR antenna. For example, when the transmitting wave from the antenna penetrates the objects, the transmitted wave will contact different materials with different dielectric constants and electrical conductivities. The penetrating ability of the wave from GPR testing depends on the electrical conductivity of the material. The depth of the penetration reduced by the increasing of the electrical conductivity of the material. The transmitted wave contains certain energy of electromagnetic. If the electrical conductivity of that material is great, the energy will be dissipated into heat and hence consuming the electromagnetic energy. The location of the steel reinforcement bar in concrete is measured by the method of ground penetrating radar. By connecting and analyzing the data of the wave using a receiver, the results can be obtained as raw results. Representation of using coloring on grayscale is usually used for presenting the results. But there are two difficulties. One is requires skilled and experienced labor to apply it, as the data can be fairly raw and difficult to predict the result of using GPR. Another difficulty of using the GPR is the situation that the steel reinforcement bar is very closely to the surface of the concrete. And that situation, the time travel of the reflecting waves for the surface of concrete and the steel may be nearly the same. A network system with using the ground penetration radar will be used in this method. The system is used for testing the nearby patterns of hyperbolic in vertical. The nearby hyperbolic patterns which have negative polarity will be required to test. The purpose of testing is to examine if the near hyperbolic patterns with negative polarity are close enough to the chosen hyperbolic pattern or not. The recording of the hyperbolic patterns of both positive and negative polarity will be done if the hyperbolic patterns with negative probability are close enough to the chosen nearby adjacent hyperbolic pattern. There will be different groups of hyperbolic patterns after recording. After calculating the value of different groups, the high-quality value of the specific group is the lateral location of the steel reinforcing bar. After identifying the lateral location of the bar, the depth from the concrete surface to the steel reinforcement bar is required to identify. This can be done by using a radar receiver for receiving the reflection of radar wave when it is located directly to the steel reinforcement bar. The starting time is described as the time which has the largest signal intensity, and by analyzing the difference from the apex of the hyperbolic patterns which have the positive polarity and the starting time, the identification of the depth from concrete surface to the steel reinforcement bar can be done. In testing the corruption of steel reinforcement bar, a GPR with short wavelength of electromagnetic wave is applied in the testing. When the electromagnetic wave travels in liquid or solid, the speed will be greatly reduced. The speed of traveling in other medium can be calculated with long dielectric permittivity, electrical conductivity, and the material of the medium. The attenuation of the wave signal is directly affected by the electrical conductivity, dielectric permittivity, and the magnetic permeability. This means that wave traveling material with great conductivity will be attenuated greatly. The figure is one example illustrating that how the GPR antenna can test the location of the steel bar and the existence of the corruption. The GPR antenna will be moved along the vertical line at uniform speed. When the antenna moves towards the concrete, electromagnetic waves are transmitted into the concrete with constant dielectric properties, so reflected wave signal will be in constant rate. However, the reflected wave signal will show a sudden change when the antenna moves towards the steel reinforcement bar due to the different dielectric properties between the concrete and steel. The dielectric constant can be calculated using some formulas by recording the signal of reflected wave. After calculating the dielectric constant of different parts, the location of the steel reinforcement bar and the location of the corrosion parts can be obtained.
Next, I will talk about the radiographic test, which is another non-destructive test for using radar and EM wave. And the basic principle of radiographic test is making use of radiation, and the radiation will pass through the material here, the test material, and provide a record on the film. The radio source of the radiographic test is usually gamma ray or X-ray. It will be used for particularly used on steel structure on identifying cracks, voids, any welding defects, and the welding discontinuity. Here are some equipment of the radiographic test, including portable X-ray and the gamma ray machine, and the recording medium are usually films, fluoroscopic screens, or digital video image monitors. Recently, there are some new technology that the films can directly convert the record medium data to the computer and use for instant analysis. This is the portable X-ray machine and the gamma ray machine photograph. Radiographic testing on steel. There are the feature of the radiographic testing on steel can be shown here. The first feature is the poor connection. Poor connection refers to it can be shown on the recording media that large dark irregular spots are shown on the film, and the base materials are it indicates that the base materials is not sufficiently melted, causing a collapse. And the inclusion is another problem found on steel structure, and it can be tested by radiographic testing. It will appear as ejected and asymmetrical dark spots on the recording film. Here, the slack inclusion, which is the dark spot it appear on here on the radiographic film, and it is resulted from the non-metallic material and trap between the welding material and the base material, causing an inclusion problem. This is the porosity. It is further classified into normal porosity problem and cluster porosity problem. Porosity is caused by the gas entrapment during the solidification of the welding parts, or excessive moisture found in the flux-coated electrodes. And they share similar image on the recording media. Normal porosity will have a dark round and irregular spot that appear singularly, like shown in this photo. And cluster porosity will have concentrated dark round and irregular spot shown in here. And this is the actual recording media image of cluster porosity. Here is the dark spot. Okay, higher radiographic density is recorded when compared to the surrounding area if a porosity problem is found on the steel structure by radiographic testing. Last problem is the lack of fusion and the penetration in welds. Incomplete. This is a cross-section of the steel showing what is incomplete fusion and incomplete penetration. The cause of the problem is the improper fusion between filler material and the base material, or the insufficient reaching depth of the filler materials. On the recording media, it will be appear. If there is lack of fusion, dark lines will be appear, and if there is a lack of penetration, straight edge will be appear. Like this straight line in this photo is showing a lack of penetration. What are the mirrors of radiographic test? It has 5 major mirrors. The first one is the provision of visual image. That the record result can be shown on the radio, or the radiograph can be shown on the recording media and causing a visual image. And the second mirrors is the permanent record. The record of the test can be kept permanently. And complex shape inspection are also available. And both metal and non-metal can be inspected by radiographic tests. And finally, the real-time building can be successful by using radiographic tests and by using the new films mentioned before, which can transmit data immediately. However, radiographic tests also have some limitations. The first one is the health hazard include due to the radioactive radiation and the radioactive salts. If stored improperly, there will be health hazard. The possible solution of health hazard is here by using distant operation by the crane out device, which provides a distant operation and health hazard can be minimized to the operators. The second limitation is the required access to both sides of the material, and this can be solved by the backscattering of radiographic testing, which the backscatter radiation is measured, and so that we do not need to reach both sides of the material to have a both side material radiographic testing. Finally, the fluctuating radiographic sensitivity may be a possible limitation of radiographic tests. The fluctuating radiographic sensitivity is caused by the size of the improper size of radioactive source, or improper source and material distance, or improper material and recording media distance. And penura, which is a geographic term describing the described in here in this photo, and this part of the recording media will be blurred or will be in improper situation due to the penumbra problem, and therefore the possible solution to minimize the poor radiographic sensitivity is to decrease the size of radioactive source increase the distance between source and materials, and also decrease the distance between materials and recording media. I'll hand over to the next student.
I will talk about the steel formwork in superstructure. What is formwork? Formwork is a container into which or against which the concrete is cased to the required desired shape, but it's modeled or featured massive and slider, exploded or only used in temporary structure. To achieve the structure that satisfies the demands of the structural and architectural designer, it is essential that all who are involved in formwork design, construction, and supervision should have a sound working knowledge not only of formwork operation, but also the methods and the material involved. The material selected for the formwork is construction and fit of the form components that will have the greatest impact in providing a good structure. Formwork must also protect the concrete during curing and support the mass until sufficient monitoring has been achieved to enable the newest cased concrete itself to contribute structurally. Once each stage has been reached, the container must be such that it can be removed for reuse and in further construction. Let me talk about the characteristics of steel formwork. Steel is stiff material, and therefore it is much more durable than timber formwork. It also possesses the following characteristics. It's able to form longer spans and slimmer in section. It is suitable for projects with repetitive design such as public housing. Steel is heavy and needs the assistance of tower crane to relocate. Higher initial capital input, but lower average cost if used repetitively used as a steel formwork. It is more difficult and more expensive to change the shape, therefore low design flexibility. Also, steel is recyclable, higher scrap value. Steel formwork is widely used in the perforating factory for repetitive due to its durability. Besides, it also gives a better surface finishing. However, the ultra smooth surface may result in poor bonding with subsequent finish. Bush hammering may be applied to the surface in order to provide improving in bonding with subsequent finish. Then I will talk about some steel section used in formwork framing. All the normal hot rolled solid steel sections are used for formwork framing, such as angles, channels, universal beams, and universal their use is for long-span framing members in large formwork units. All these sections are available in a normal grade and some in higher grades. Hollow section, round, squared, and rectangular are used in formwork. Round tubes are used in the round form for bracing and when equipped with suitable end fitness for soffit supports. Round tube is the base material for the fabrication of most properly framed systems. Modular support system, square and regular hollow sections are fabricated into some products. but their main use is in purpose building formwork.
Hi, it's me Napoleon, and I'm responsible for talking about the types of formwork in terms of the material used in order to compare with the steel formwork. And the first type of material I would like to introduce is the plastic one. And plastic is a byproduct of oil, petroleum, so that their cost is relatively high according to market. And the plastic is flexible with an extremely low elasticity value. And plastic is impermeable material tend to produce some surface blowholes, which is not acceptable for the concrete, and it will release, and the release agents will be used according to different form of plastic mixtures, and I will talk about it in the following part. And the first plastic I would like to share with you is the polypropylene formwork, and the lightest thermoplastics. It is resistant to wear and abrasion, and the component within the polypropylene plastic are significantly durable and can withstand the rigors. And the components of the polypropylene formwork would be injection molded. Use the release agent here or prolonging the life of the mold, and the hot gas welding is applied to repair this kind of plastic. And for the next type of the formwork is the rubber formwork, and rubber formwork is elastomeric materials and are generally used as foam liners. And different types and grades of the materials are used, including polyurethane and polysulfide and silicone and polyphenol chloride. The preformat or mold in a wide range of design or proving liquid resin that enable an infinite range of design. And the cases release agent are advised, but some degree of the self-releasing is fine in the rubber, but it is still be advised. Then for the plastic sheet, the third one, it is a thermoformed plastic sheets are used as a form of liner to produce low relief patterns, and the material could be polystyrene and acrylonite and butadiene, styrene, polyphenol chloride, and other kinds of thermoplastics. And the size of sheet depends on the frequent former. And the last type of the plastic formwork would be the foam and expanded plastic, and it is one of the most common material used in expanded plastic is the expanded polystyrene. According to the British standard 3837 reference 36, the expanded polystyrene should be specified because of its combustible material, and some grades incorporate a fire retarding agent. And in the British Standard 6303 reference 37, the guidance on its fire characteristics and fire performance is given. Removal methods using heat or high temperature are not recommended because of the combustible properties, and non-flammable solvent and coolants which do not produce toxic fume are preferred. Then I will talk about fiber, and fiber is from a French word, and fiber is a rope or a string used as a component of composite materials, and it is used to make the product like the paper and papyrus or felt or clothing or some other chemicals like the strongest engineering materials often incorporate fiber. For example, the carbon fiber, the ultra high molecular weight polyethylene, and the two other examples I will talk about in this part. The first one is the fabric. Fabric is the artificial fiber, renowned, and the engineers had developed a number of proprietary fabric materials since the mid-1960s, and the coarse open grade material is usually made from an oriented polymer. The material of the grade will be suitable for transmitting tensile forces. And the second type of the formwork would be the glass fiber reinforced plastic formwork. It is a strong, lightweight material generally used as a formwork, and it produces high-quality pattern surface finish. The high proportion of blowhole may be formed in the concrete, tendency for concrete surface to craze, and the joint may be produced and cause a serious problem. And to solve the problem, we will use the suitable release agent, and care must be taken to ensure that the stress are evenly allocated in the laminate to prevent the concentration of the stress. Okay, now we talk about the metal, and metal is very common, and the steel of our topics is also a metal, alloy, consists of metals. They commonly used in construction tools, machine, and equipment like helmet or the machine, the crane, car, dozer. And different metals consist of distinct properties. The hard, ductile, impermeable, and the metals, one of the best advantages of the metals is it can be shaped easily. So I will talk about the aluminium in this part, and aluminium is a weight-saving metal, and the airplane also are made of aluminium. And some problems of reacting with alkalis because it is a reactive chemicals, reactive elements, and we would use the release agent to minimize the reaction among the concrete, the alkaline concrete, and the aluminium. And the best part of aluminium is it is flexible and many possibility on electrical design. So we can make some curve, some arc, or some shape you can imagine. And okay, this is the comparison part, and the steel of our topic is included in the metal, and we'll talk about the cost first. Plastic and fiber is relatively high because they are made of the petroleum, and the filtration and the production cost is quite high to make a plastic. And the metal will be the medium, and the lowest one will be timber. And when we talk about more environmentally friendly places, we will talk about the recycle and can it be reused. And the plastic, of course, it can be reused many times, but depends on the types, because some types of the plastic formwork can only use not more than 100 times. And fiber, yes, of course, fiber is a very strong and durable material, and metal, of course, and the timber cannot be used for so many times because it will rot and it will rust, and it is easily broken. And about strength, the plastic is very low if we don't use back lining, the back fixing to support the flexible plastic. So it is very low in comparison, and fiber is higher because due to the great structure, and the metal is high too just because of the metallic bond, and the timber is medium. The complexity of applying it in the construction site, in terms of plastic, the production and the implement is very complicated for the plastic because there are many molding, shaping, and you have to add some release liquid, something to prevent the bubble, the blowhole, and the floor and the joint. And for fiber, it is high due to the artificial production. And for metal and timber, they are relatively lower than the fiber and plastic because they are people just extract it from the environment, from the nature, and then do a little on it. Then you can proceed a little. And for the ease of design, the plastic and the metal is very high and are very easy to design because they are flexible, they are ductile, they can shape into any shape you want. And the fiber and timber, because they are hard and timber is some biological reasons, so timber cannot be shaped into into too many shape for concreting. And for the risk, plastic will have a higher risk because plastic will cause a blowhole and joint and too flexible to fall, to broken, to damaged. And fiber and metal is medium. They are not easy to broken. And timber, although it is easy to broken for timber, but actually we seldom use timber for more than for so many times. So the risk of timber will be eliminated because of it is not well used. And this is the end of our presentation. And in this presentation, we have talked about the properties of steel and some inspection methods of the steel. And then my friend Neil has talked about some formwork made by steel and the mechanism, the function, the properties. And I have compared the steel with other types of formwork made of in terms of the material, and we are sorry for the resolution or the voice in this video, but we hope you will enjoy our presentation, and thank you for your attention.